Guys, we're going to learn some circle vocabulary today. The first definition is the definition of what a circle is. And the circle is a set of all points in a plane that are equidistant from a given point called the center. So on the diagram here at the right, I'm going to label the center of this circle with the letter A. Okay, so we can call this circle A, because that's how we name circles, by what their center is. Or we can use the symbol for a circle and then write A. Okay, so A is a point that is the center of the circle. Okay, our next vocabulary word is a radius. A radius is a segment. Okay, so there's no arrows that is from the center of the circle to a point on the circle. So we're going to use the same center, A, and now I'm going to name this point on the circle as B. And then I will write AB as a segment and put the segment symbol above it. And this is a radius. Okay, next vocabulary word is a diameter. A diameter is a segment across the circle through its center. So this one goes all the way from one side of the circle to the other, but it has to go through the center. Again, there's no arrows. These are endpoints on the circle. So we're going to name the circle the same as A. I'm going to use that same point that I used for the radius of B, and then I'm going to call this other point on the left here C. So the name of this diameter is CB. So we use the two endpoints to name it, and this is a diameter. Okay, next one is a chord. A chord is another segment. Just like a radius is a segment, a diameter is a segment, a chord is a segment. This one is different though because it does not touch the center. Okay, still has endpoints that are on the circle, but it does not go through the center. Okay, so we're going to name these two endpoints D and F. Okay, so DF is a chord. All right, and then we're going to move to two different lines that are a part of a circle. The first one is a secant. A secant is a line that intersects a circle in 2 points. So you can see the arrows on the ends, and then you can see the 2 points where it intersects or crosses the circle. So I'm going to call those F and G. And then when we name this, you got to make sure you put the arrows on the ends. So FG is a secant. Okay, I just want to point out the difference between the chord with endpoints that also has 2 points on the circle, but there's no arrows. And the secant extends beyond the circle, having arrows. So a chord is no arrows, that's a segment, and a secant is a line with arrows, okay, both hitting the circle twice. Then we've got the tangent. Tangent, you can see, is a line that hits the circle only once. So what I'm going to do here is I'm going to label that point where it hits as J, and then I'm going to put two other points on this line, H and K. You can choose any two of these three letters to name your tangent. I'm just going to choose the H and the K, and I'm going to put the arrows above it. This is a tangent. Okay, and then the last part A point of tangency means the point where this line hits the circle. It's right here at J. So I'm just going to draw an arrow up to that. And we're going to say J is a point of tangency. So where the tangent hits the circle. Okay, what I would like you guys to do right now using that vocabulary is I want you to take a look at this diagram in example 1, and I want you to look at each of the things that is given here that you need to describe. So you're going to use one of the words that we just learned to describe each of these things listed in A through H. Pay attention to the symbols that are written above the letters. If they have arrows, you're talking about a line. If there are no arrows, you're talking about a segment. So I'm going to pause the video and give you a chance to be able to fill in what you think they are. You should pause the video as well. All right, I hope you've had a chance to fill each one of those in. Now let's look at each of these together. So I see that I have arrows on the end for A. So that's a line, which tells me it's either going to be a tangent or a secant. So I need to see, does it hit once or does it hit twice? Here is HG, right here. So that is a line that hits the circle once. It's a tangent. The next one, CB. C is the center, going to an endpoint of B on the circle. So this is a segment from the center to an endpoint on the circle is a radius. EF, look at the notation here. There are no arrows. So that's a segment. So that is starting here, ending here, connecting the two. So that's a segment with endpoints on the circle. That is a chord. Next, we have arrows. So that's going to be a line. So from G to F, hitting the circle twice. That is a secant. And we've got DB, so endpoint to D endpoint. I went through the center, so this is a diameter. For A is just a point, and is a point that is a part of this tangent line. So it is the point where a line is hitting my circle. This is called a point of tangency. Okay. EF, and it's a line that's going through those. Okay, so that's another secant. It's a line that's hitting a circle twice. And then DC, here's C and D, connect them. That's a segment from the center to an endpoint on the circle. That's a radius. And then the very last vocabulary word here for C, it was the first one we learned above. That is the center of the circle. Okay, I hope you got those right. And if you didn't, take a look at what we have written and go back and compare the definitions above again. All right, let's move to the back to some of our tangent properties. This first tangent property says that a tangent line to a circle will be perpendicular to the radius if they are connected. So that means you're going to have a right angle right here. How are we going to use that? Let's come down to example number 2 and I'll show you. So example number 2 is telling you that you have a tangent line right here. I know it looks like a segment because it's cut off, but this is going to be a tangent. We cut them off so that you can see the triangle here in these type of questions. Okay, so this is a right angle. And then I hope you can remember from your last unit, we would use a Pythagorean theorem if we were solving for a right triangle. So the piece that we're missing right here is the hypotenuse. And then we're going to do our Pythagorean theorem. Our a squared plus our b squared equals our c squared. So 11.7 squared plus 15.6 squared equals x squared. If you have a calculator that it has a display, you can type all of this into the calculator at one time, and you'll get 380.25 equals x squared. And then what you do is take a square root of both sides, and we're going to round to the nearest hundredth if necessary. So this one, we get 19.5. All right, I want you to try number 2b. Here's your x. I'm going to pause the video, and I want you to try and solve that one with the Pythagorean theorem. Okay, so I hope you set this up as 13 squared plus x squared equals 19.4 squared. So this would be 169 plus x squared is 376.36. And when you subtract 169 from 376.36, you'll get 207.36. And then, just like we did in A, take the square root of both sides. And this time you'll get 14.4. Letter C is a little bit trickier. And it's trickier because you're looking for this piece, but you don't have this part right here. The radius of this circle is 4. Well, a radius in a circle, no matter where it is drawn, will always be the same. So that means that this has to be 4 as well. So what I have where my right angle is, and I forgot to draw that right angle in B. In letter C, I've got 4 squared plus x squared. That's my A and my B. And then I need my hypotenuse, which means I'm going to need to add those two together. So my hypotenuse will be 8.5. So here, 16 plus x squared is 72.25. Subtract 16 from both sides. X squared is 56.25. And then you're going to take the square root of both sides. And you will get x is 7.5. Okay, so anytime you're given that this piece is a tangent and you've got a radius, it means that this is a right angle and you're going to use the Pythagorean theorem. Okay, all right, we're going to go back up to our tangent properties and we're going to look at the second one. So the second property says that if you have two segments, so this would be the segment from A to B, and then from C to B. So I say a segment because we're just talking about the piece from the tangent point to the outside point of the circle. If you have two tangent segments, okay, that are coming from the same point, then that means that these two segments are going to have the same length. Okay, not the part that extends here, but just the part from where it touches the circle from the point on the outside. If we come down to number 3, I'll show you what this looks like. So on number 3, we're being told that K and M are both points of tangency. So since we are coming from the same point C to that tangent point, and then from C to the other tangent point, it means that these two segments have the same measure. So x plus 3 is 7, subtract 3, and x is 4. Same thing on letter B. J is your outside point. You're going to the tangent point K and to the tangent point M. It means those two segments are congruent, or they have the same measure. So 4x plus 7 equals 7x minus 8. So I'm going to subtract 4x from 3x. Or sorry, I'm going to subtract 4x from 7x to get 3x. And then when you add 8 to 7, you're going to get 15. And then when you divide by 3, x will be a 5. Okay, last one here on 3, letter C. So these will be congruent. So 3x squared minus 10 is 17. Add 10. 3x squared is 27. Divide by 3. X squared is 9. And then we're going to take the square root of both sides. And we're going to get that x is 3. Okay, we're going to use that same property for examples 4 and 5. These are what we call walk-around problems. They're going to look similar to number 3. We've got lots of tangent segments. They're going to be congruent. I'm going to start on the top here at number 4. Got this tangent segment right here, 6. So if this is 6, then BD should also be 6. And then I'm going to come down here and look at CF. If this is 8, then CE should also be 8. And then my last part, if 8F is 12, then that means that AD should also be 12. So when example number 4 asks for me to solve for the perimeter of the triangle, we're going to cross this off for X. We're going to solve for the perimeter of the triangle. The perimeter means that I want the distance all the way around. The perimeter is 2 6s. I got 2 8s. And I got 2 12s. So walking all the way around here, I have 6 and 6, 8 and 8, 12 and 12. That's why we call them a walk-around pattern. Right? And if we add all of those together, we get 52. And then I put units on there because we're talking about a perimeter, which is the distance. And normally we would say something like feet or inches or yards. And since I don't have that, I just call it units. All right, let's do that again for example number 5. I can see this is 6.7, so that means that this will also be 6.7. And then I've got a tangent segment here of 8. So it means the tangent segment above that will be 8. And then the only part that I'm missing is right over here. But since I know all the way across is 12.4, and if this part here is 8, then right there would be 12.4 minus 8, giving me a 4.4. And then this piece will also be 4.4. So my perimeter there, I have 2 6.7s. I have 2 4.4s. And I have 2 8s. So this perimeter would be 38.2, and then put your label on there of units. Okay, so that's the tangent properties. The vocabulary is on the front, and we've got the properties there on the back. It should follow along pretty closely with the practice homework that you have to do for today. So get started on that. Have a good day, guys.